Light can make us see everything in the world, but have you ever wondered how light travels? How can you see yourself from a mirror? And why this pencil looks like pen in this glass? Well, it's all about reflection and the refraction of light. Hi, I'm Huiyan Li. I'm a student at the University of Rochester, Institute of Optics. This channel, Wisdom Optics, is all about introducing optics and physics to you in an easy and interesting way. Now, let's go ahead and jump into today's video. First, let's talk about reflection. When we turn on a light source in the room, it can make us see everything in that room. This is due to the light, but the light we perceive are the reflections of light. So what is reflection? Reflection is a bouncing of light when it hits something. So when we turn on a light source in the room, the light hits a wall and bouncing back and forth in the room. Some of the light enters your eyes, and that's how you can see the room. The sun is another light source as well. It can hit trees, roads, buildings, everything. The reflected light enters your eyes, and that's how you can see the world. The rays coming from the light source and hitting the surfaces are called incident rays, and the rays bouncing back and reflected from the surfaces are called reflected rays. The reflected rays leave the surface with the same angle as they strike. So if we point the light to a surface at a 30-degree angle, which is the angle of incidence, the light will be reflected off the surface at a 30-degree angle, which is the angle of refraction. So the angle of incidence is equal to the angle of reflection. It's called the law of reflection. Now, why does this pencil look like bend in this glass? Well, you can blame the refraction. When light travels from one medium to another, it bends. Here, light is traveling from air to water, our two different mediums in this case, and this is known as refraction. But what do we mean by two different mediums? Because water is denser than air, everything travels slower in water than it would in air. This also applies for light. Light is traveling slower in water, and the direction will be changed due to the difference of densities in two mediums. The measure of the density of a medium is called the refractive index. It describes how light propagates through that medium. Light travels fastest in the air, and the refractive index of air is almost 1. But the refractive index of water is 1.33, which means light travels 1.33 times faster in the air than in the water. The extent of how light will be bent in two mediums is determined by Snell's law. N1 times sine of theta 1 is equal to N2 times sine of theta 2. So let's say N1 is the refractive index of air, which is 1, and theta 1 will be the angle of incidence. So N2 is the refractive index of water, which is 1.33, and theta 2 will be the angle of refraction. So when light travels from air to water, because the refractive index of air is smaller than the refractive index of water, so the angle of incidence will be larger than the angle of refraction, and the light will be refracted towards the normal of the surface. The higher the refractive index, the closer to the normal direction the light will travel. So today, we talk about the law of reflection. The angle of incidence is equal to the angle of reflection, and the law of refraction, Snell's law. But you may be wondering, why these are important to you? Well, reflection and refraction are the fundamental principles of geometric optics. It determines how light travels and propagates, which can be used in complicated lens systems, such as cameras, telescopes, and microscopes. Refraction can be used by the lens to form an image of an object for many different purposes, such as magnifying or minimizing the object. I hope you were able to learn something new in this video. If you're interested in optics, please click the subscribe button and comment below with topics in optics you'd like to see in the future. If you're interested in optics program at UFR, links in the description. I'm Huiyan, and hopefully we shine light on the way you see the world.